Okay, so welcome to another video lecture series on analytic geometry. So today's discussion is on conic sections. Okay, so for this session, we will hopefully define conic sections, parabola, ellipse, and hyperbola. And also, we in this session, we will identify the type of conic section through its equation in general form. Okay, so to discuss the conic section, let me introduce to you the idea of a double cone. From the word conic section, the root word for the word conic refers to a cone, just like an ice cream cone. Okay, so what you see here is a double cone that is drawn end to end at the tip of each of the cone. Now, of course, a cone is in if you're going to have a cross-section area, yeah, it would have a cross-sectional area which is circular in shape. Therefore, a circle is just a part of a bigger family of loci in the Cartesian plane known as conic sections. This family of loci is based on the following double cone. Okay, so just like what we have discussed in the previous video lecture on circles, a circle is simply a collection of points that is equidistant from the center of the circle. So this means that a circle is simply only a portion of what we call a conic section. Okay, so what is illustrated here is that there are two circular conical surface placed from point to point or vertex to vertex in such a way that their axes are parallel. These axes together form the axis of symmetry of the double cone. Now, of course, the double cone or the cone extends indefinitely in the upward direction and in the downward direction. Now, if we're going to draw a line from the center of the above cone, from the center of the circle, passing through the connecting point of the vertices of the two cones, ending up with the bottom cone, we call this imaginary line as the axis of symmetry. Where the axis of symmetry and the vertices of the two cones meet, we call this the center of the conic section. If we're going to draw a line that passes through the side of the cone, the upper cone, passes through the center of the conic section, and passes through the other side of the lower cone. If this line is a straight line, this straight line is actually a tangent line. Now, it is defined as the tangent is actually defined. If you're going to recall this in your trigonometry, the tangent line is defined as the line that passes through a given curve, touching only one point on the curve. Now, a conic section is defined is the intersection of a plane and a double cone, or a portion of the double cone. Now, in the figure, the possible formation of the conic section, if we're going to make use of a plane, the corresponding figures that could be formed in our plane could be any of the following. It could be a parabola, it could be a circle, it could be an ellipse, it could be a hyperbola. Now, in order to form each of this figure, we try to make use of what we call a conic section, which is the intersection of a plane and a double cone. Now, to illustrate, we have the following illustration. Consider the following illustration. Now, in our definition, a conic section is the intersection of a plane. Now, that plane is referred to as is the one that we see here in the figure. Okay, so each of this plane cuts a portion of the cone in several ways or several manners. So what whatever figure that will be formed in the area of the plane would be considered as a conic section, and it is the intersection of the plane and the given cone. Okay, so if you try to imagine that if you're going to cut the upper cone with this plane, it will be tracing the shape of the cone sideways from the back of the cone to the front of the cone. Remember, this is a three-dimensional figure. Now, that shape corresponds to what we call a parabola. Okay, so doing another cross section, if we're going to have the plane in a horizontal manner, horizontal with respect to the plane of the circle, or the bottom or the above circle of the conic section, then the figure that will be traced on the plane is actually a circle smaller in size if it is actually uh, between closer to the vertex as compared to the base of the cone of the two cones. Now, of course, if you're going to move the plane closer and closer to the base, you will have a greater and greater size for the circle that will be traced on the plane. Okay, so this means a parabola is a conic section. A circle is also a conic section. Okay, so next we have the ellipse. The ellipse is actually somewhat circular in shape, but in order to trace the shape of the ellipse, you're going to have the plane of the circle tilted to an angle with respect to the base of the cone. So you will be tracing, instead of a circle, you will be tracing an ellipse or an oblong. Okay, so finally in the figure we have what we call a hyperbola. A hyperbola is simply a parabola that is of mirror image with respect to the line of the vertex of the conic section. So you have a parabola with respect to the upper cone, and you have a parabola on the lower portion of the cone. The combination of the two parabolas forms what we call a hyperbola. Note that there are other possible intersections of a double cone and a plane. Some of them would include the point and the crossing of two lines, which forms this figure. Now we consider these two figures, the point and this cross section of two lines, as trivial intersections, and implicitly exclude them as conic sections. Okay, so we'll now be focusing individually on the conic sections that was presented earlier. So first one would be the parabola. Now a parabola is an intersection of a double cone and a plane parallel to the tangent line of the double cone. The parabola generally takes the following form, has this sort of shape, and has the quadratic equation y is equal to x squared as its basic form of its equation. Y is equal to x squared is the equation for a parabola. Now the circle is just like what we have discussed in the previous discussion or previous video lecture on the circle. The circle is an intersection of a double cone and a plane perpendicular to the axis of symmetry of the double cone, or simply the plane is actually parallel to the base of the cone. Of course, the circle, we are familiar with the basic shape of the circle. It takes on the basic equation r squared is equal to x minus h squared plus y minus k squared, and this was discussed in a separate discussion on circles. Next in our discussion is the ellipse. The ellipse is a conic section resulting from the intersection of a plane into one of the cones of a double angle such that it is not parallel to any tangent line and not perpendicular to any axis of symmetry. The ellipse generally takes on the following form. Now, lastly is the hyperbola. The hyperbola is a conic section resulting from the intersection of a plane of two of the cones of the double cone. A hyperbola generally takes the form of this shape. It could be sideways, it could be above ways, depending on whether the conic section is right side up or on its side. The equation of a conic section can be generally described in the form of ax squared plus bxy plus cy squared plus dx plus ey plus f, and is known as the general form of the conic section. Now, of course, a, b, c, d, e, and f are constants, whereas x and y are considered as the variables, the independent and the dependent variable.